Hi everyone, I'm Norwish and today I'm here with Suraj to present our Lab 7 fatigue failure case study for the machine design lab. So we decided to study the Versailles rail accident, which occurred in Versailles, France in 1842. This accident was one of the most severe during the time, resulting in 50 to 200 deaths. This was also one of the very first accidents due to fatigue failure, so you could say that this accident was one of the catalysts that led to the theory of fatigue failure that we use today.
Hey guys, it's Raj here. So moving on to the crack discovery and its consequences. Interestingly enough, no matter how much we looked into the accident, we weren't able to find any source that explicitly stated that the crack or source of the failure was ever discovered. At the time, no one knew fatigue failure even existed, so this left engineers wondering what went wrong. One reason for the lack of the theory of fatigue failure is that back in the day, everyone just thought that failure only occurred when the stress experienced by the part was greater than the ultimate strength. But obviously, now we know that there's more to it than just that. Due to the severity of the incident, this led to serious investigations, one of which was led by William Rankine, who eventually proved that fatigue failure existed. And this led to the development of fatigue failure theory and SN diagrams.
Next, we'll talk about how the root cause of the accident was identified. As mentioned on the previous slide, at the time, no one even knew that fatigue failure existed. Therefore, following the accident, several theories were developed, including some incorrect ones. One, for example, as a bit of background, when manufacturing parts, techniques are often used to strengthen the material. Recrystallization is the process of reverting the metal back to its initial state before it was strengthened, which is essentially equivalent to weakening the metal. We now know that recrystallization can occur when the metal is sufficiently heated, but back in the day, one theory stipulated that stress could cause metal to recrystallize or weaken, which eventually led to the Versailles failure. But we now know that that theory was wrong. So, a couple of years after the accident, William Rankine finally proved that train axles often failed by progressive growth of a brittle crack from a stress concentration on the axle, which we now know as fatigue failure.
Hey guys, it's Raj here. Moving on to the solution to the failure. After the discovery of fatigue failure by Rankine, many techniques were developed so that fatigue failure could be prevented. One of the most useful ones today is the SN diagram, which I suppose we're all very familiar with. This diagram was developed by August Voller. As we all know, this diagram is very useful and simple because all we have to do to ensure infinite life is to design a part such that the stresses on the critical elements do not exceed the material's endurance strength. Hey guys, so moving on to the efficacy of the solution provided. So the solution in this situation are SN diagrams. And so here's the thing. So after SN diagrams were invented, train axles actually broke much less often, with the majority of accidents being due to negligence. So this means that for the most part, the design of axles using SN diagrams proved to be very good. As we also know today, SN diagrams are still very useful and they are applicable in nearly every industry. Therefore, I would say that its usefulness couldn't possibly be understated.
Finally, some design improvements that we suggest to be applied to train axles, or at least to train axles back in the day, are to make use of modern shaft design techniques such as large radius undercuts on this left image here, shoulder relief grooves in the middle, or large radius relief grooves on the right. And also to make use of shape synthesis principles, such as using hollow axles maybe. The use of these shaft design techniques should improve force flow and reduce stress concentration within the axle, whereas the use of a hollow axle should decrease the stress magnitudes. And that concludes our presentation. Thank you very much for listening.